All right, so we've got a bucket that's being whirled vertically. Um, and we know at the lowest point, we know some information. So I'm going to draw the bucket in the lowest position. So there's a rope down here, and the position is at 1.20 meters. And I'm going to call that L, or you know what? It's easier to work with R. Okay, so then we've got a bucket down here. I guess I'll just kind of draw a bucket. Maybe it's an Easter basket. Okay, so it's going to spin around in a circle. That sounds like fun. Okay, the mass is 2 kilograms. And the tension in the rope. So if I draw a free body diagram here, I've got the tension in the rope acting upward, which is 25 newtons. Then I'm going to have gravity acting downward. And then I'm also going to have the centripetal force acting downward as well. So, this is going to be, you know what, I'm going to write this somewhere else, and I'm going to use a different color. V squared over R. And gravity is going to be mg. So the sum of the forces in the radial direction is going to be 25, or F sub t, minus F sub g minus F sub c. So we sum those forces, we should get 0. Um, so what am I trying to figure out? The speed of the bucket. So let me substitute some things in here. So m times g plus v squared. I'm just rearranging here. So divide by m and subtract g on both sides. And then I'm going to multiply by r and take the square root. Okay, so let's put that into a calculator. I'm going to clear off my calculator first. Okay, square root, and I am going to call this v, square root of r times f sub t, which is 25, over the mass, which is 2, minus 9.81. Oh, and R, we know the number for R. R is 1.2. So that gives me 1.8 meters per second. So it looks like we've got two significant digits, so that should be 1.80 meters per second. All right, so that's the answer to part A. Part B. How fast does the bucket have to move on the top so that the rope doesn't go slack? So let's just draw this again, but we'll draw it on the top. Okay, we got the bucket up here. I'm not sure if I have enough room, but I think I do have enough room to draw it. Now, up there on the top, we're going to have gravity pulling down on the bucket. I guess I'll draw it over here. The centripetal acceleration is going to be opposing gravity, and we need these two to equal each other. So in part B, Fc equals Fg. Draw. F sub c equals F sub g. M v squared, this is going to be a different v, over r equals mg. The masses cancel out. Solving for v, v is going to be the square root of g times r. So square root of g times r gives me 3.43 meters per second. And that's the answer to B. So the speed must be greater than or equal to 3.43 meters per second. Thank you for watching.